Hey, what is going on, class? Welcome to a little video going through an example of factoring. So this is one of those skills that you're going to learn why it's important here in about a week or so from the time of the test for this, and from the time of even right now when I'm recording this, it's going to become really important during quadratics. But for right now, it's just a skill that you need to understand how to do, kind of like multiplication. You need to know how to multiply 12 times 11. Not because it's important in and of itself. I mean, it is important, don't get me wrong. But it's important that you know how to do it because then you can do things quicker and you can do problems faster than the tedious and monotonous way that you have to do it otherwise. So let's take a look at a function. Let's say we have a function f of x equals 5x cubed plus 10x squared plus 5x. We're just going to start off with something like this. And the reason for this is so that we just have one example to where you get all the steps. So first thing you want to do is look at the equation. Is there a GCF? Which hopefully you're sitting there and you're like, there's always a GCF, Mr. Curry. That's a bad question. Well, it's not a bad question, but it's an important one. Is there a GCF? Then you need to ask the question, does the GCF equal 1? If it does, then we can kind of do this whole, let me go like 0.1 scale here. If the GCF equals 1, box it. Otherwise, as is this case, the GCF does not equal 1, which means that we need to come in here and go, okay, factor out the GCF. Well, we can see that our GCF up here is, well, we can divide 5, 10, and 5 by 5. It's the biggest thing we can divide all of them by. And we can see that each one of these has an x. And smallest power here is 1, so we need to pull out an x to the first. So then we can rewrite this thing. Let me copy this piece. So my GCF is this thing here. But what I'm doing down here is I'm breaking this apart. I'm rewriting this. This is a new way that I can write my f of x, which means pulling out, I'm going to divide this by 5x. The 5's cancel, and I get just an x squared. So I get x squared plus 10 divided by 5 is 2. What are you doing? Sorry about that. I don't know why my iPad keeps quitting out of this program, but we get 5x there plus 5x divided by 5x is 1. Whoops. Sorry, I got a little flustered. 10 divided by 5 is 2. So now we're back over here in this question. Well, now we have a new piece that the GCF is 1. So we're going to box that. So at this point in this problem, we are applying the skill that you would do immediately. If you had just gotten this question, you would immediately jump into this part of boxing it to factor it out. So we're going to take, I'm going to color code this. So that first thing, the thing with the x squared, is going to go up here. That last term, it's just a number, is going to go down there in the corner. Our middle term here goes here next to the adds 2. And let me find one more color. How about red? Then we're going to multiply diagonally across and get that that is x squared. This is the bare minimum. If you don't put anything like this, you get 0 points on whatever it is that we're working on. So it's really important that you can at least copy what I'm doing. next up, the question is, okay, from the box, what are we going to do here? Now, you're asking yourself the question, what multiplies to x squared and adds to 2x? Well, which one's easier to ask? Well, how many things add to 2x? Well, we have 1x plus 1x, 2x plus 0x, 4x plus negative 2x, 5x plus negative 3x. We can just keep going on this path. There are infinitely many things that add to 2x. But how many things that are whole integers? We need integers here. Integers. This is the mathematical symbol for the integers. We need whole numbers that multiply to 1. Well, there's only one set of whole numbers that multiply to 1, and that is 1 times 1, which alternatively, 1 plus 1 equals 2. So what multiplies to 1 and adds to 2? Well, it's 1 and 1. So you're going to take these and you're going to put them here in these boxes, and it doesn't matter which one because it's a 2 by 2. It works itself out. I will instruct you further if we go into bigger boxes, but for right now, we're only going to factor things that go into a 2 by 2 box. So now you need to find your GCF of each row and column. And you're going to pull it that direction for the top and out to the left for the rows. So we're looking for, what is the GCF of x squared and x? Well, I can divide both of those by a single x. Same thing here, x squared and x, I can pull out an x. Then from both of these, x and 1, well, they only share a 1. So what this tells me is that this is the factored form. So I had this is my factored form, which says that I have f of x equals that GCF, don't forget the GCF, times x plus 1 squared, because I have x plus 1 times x plus 1. I can write it as a square, and I don't have to write this binomial twice. So this is one of the foundational skills. We're going to later on go into how we can use this to graph functions quicker. Also, this tells us something about the roots that allows us to just instantly get, in this case, 3 points for free in our graph. So that's why this is so important. It is vital that you know how to do this, because I will personally promise you this will be on every single test from here to the end of the year. So it is very, very, very important that you know how to get this from this. If you have any questions, if you're confused in any way, please come in and talk to me. We can sit down, do problems together, and just work through it until it makes more sense. I hope you're having a great day. I hope that the class is making sense to you. If it's not, please come talk to me. I am here all the time, just waiting for you to come ask questions. So I hope you have a great day, and I will talk to you in class.